Hello and welcome. This is a lesson on our solar system. Get ready to learn. This shows the relative size of our sun and the other planets, and we're down here. Tiny. Did you know that the sun and all the objects held by the sun's gravity is they're known as the solar system? That's pretty much the definition. All the objects held by the sun's gravity. The Greeks recognized 5 planets: Mercury, Venus, Mars, of course Earth, Jupiter, and Saturn, because these are the 5 that they could see. The word planet comes from the Greek word meaning wanderer. They would wander across the sky. And there are now 8 planets. Pluto, it's a dwarf planet, and as are many others that are dwarf planets. Why is this important? Well, at one time, people on the Earth thought they were in the center of the universe. Everything went around them. And that's just not true. Knowing our place in the universe helps us to understand it a little bit better. Ptolemy. He was an ancient Greek, 1,000 years ago, 2,000 years ago. He thought the Earth was the center of the universe by observation around 150 CE, Common Era. And everything else went around the Earth. That was his theory. The geocentric model that he came up with, geo meaning the center, or meaning Earth, geocentric, Earth-centered. It's his idea. And the layers of the sphere and the things in the sky were attached to a sphere. Well, it kind of makes sense. If you're going around, think of an onion and different things going around in different layers. Planets appear to move faster than stars, so they were placed in closer. This is strictly by observation. As years gone by, Nicholas Copernicus, he came up with something a little bit different. He made a model where the sun was the center of the solar system around 1508 CE. So, 500 years ago, a little over, he said, wait a second, if the sun is in the center, everything works. It's called heliocentric system. Helios meaning sun. So if the sun is in the center, all the observations actually work, and it better explain the movement of the planets. Now, Kepler he was building on Copernicus, but he was a mathematician, and he used mathematics to describe planet motion. The orbits around the sun, the revolutions around the sun, they're not round. It's not a circle. It's slightly off. It's called an ellipse, not an eclipse, but an ellipse. An ellipse, let's see, a circle has one center, an ellipse has 2. And that's because of the different gravities that the sun and the planet, or the planet and the moon, whatever is revolving around the other, influence each. And he also saw that the closer you came to the other object, the faster you went. So the further away, it's slower orbit further away from the sun and faster as it came nearer. Now the orbits are ellipses. Faster nearer to the sun, they're slower further away. And the orbit, this repeats over and over. It's a balance, it's a dance between the inertia of the body. It wants to keep going. There's nothing to stop it. It's a vacuum of space. And the gravity between the two objects, pulling each other towards each other. It pulls it and speeds up and then flings it away. All right, our sun. It's a nearly perfect sphere in the center of our solar system. It's made mostly of hydrogen and helium. How much? A lot. Provides most of Earth's energy by radiation. These are explosions happening all the time, giving off incredible amounts of radiation. How big is it? Well, here's Earth. 1 million Earths could fit inside the sun, and the sun contains almost all the mass of the solar system, 99.8% of the mass of the solar system. It's huge. We divide up the planets into two categories just because they're so different. We have the inner planets, Mercury, Venus, Earth, Mars. These are in the relative sizes. And yeah, you would think that Mars would be similar to Earth, but Venus actually is more similar in size. The inner planets, Mercury, Venus, Earth, and Mars, they're terrestrial, meaning Earth-like, meaning made out of rock. They're mostly made out of rock or rock-like material. Now the outer planets, Jupiter, Saturn, Uranus, Neptune, they're known as gas giants because they are huge compared to the size of, say, the Earth. They're made mostly of gases, but they're so far away, these gases are cold, like really cold. And that's because they're just so far away from the sun. They have dozens and dozens of moons, some have rings, and we're still exploring these planets. Now, between the inner planets and the outer planets are all these pieces of rock, asteroids. And they're called the Asteroid Belt because, like a belt around your waist, they circle the sun. Between Mars and Jupiter, they made millions of pieces of small rocks. Some the size of a school bus. Some the size smaller than a grain of sand. They were discovered in 1801 by Giuseppe Piazzi. And sometimes they're hit out of orbit, like they bang into each other, and they fall, because of gravity, into our planet. The interesting part is, the best place to look for these is the South Pole, because it's mostly ice, and these are mostly dark and black. They come in through the atmosphere and melt and burn. But whatever's left is usually easy to spot on the ice. The other thing is 70% of the planet is covered with water. So they hit the water and they sink and you never find them. Asteroids are similar to comets, but they lack the tail, the coma. And usually smaller. The plane of the ecliptic. If you put all the planets on a table, the sun in the center, and all the planets spinning around or revolving around the sun, they would pretty much stay on the same surface. The orbits of the planets, they're on a similar plane, similar surface. Now, the dwarf planets are not. They're on an angle. See, here's the top view, and here's our solar system if you looked like on the side. So why is this important? We once thought the Earth was the center of the universe. Knowing our place in the universe helps us to understand it and ask more questions. There's your lesson on the solar system. Hope you've learned something.